I'll give you another example. We're having here the example in 3-coordinate system x, y, and z. We have the temperature, and we give the temperature distribution in x, y, z system. This t, x, y, a functional relationship. 8 times 2x squared plus 4y squared plus 9z squared. It can be any functional relationship in x, y, z system. Now what we want to do, we want to use differential. When we say use differentials, mean we want to find the approximate values. Otherwise, we say they find the exact value, exact change. That means we use increments. When we say we use differentials, mean we want to find dt. To approximate, and the word second is coming, the approximate. The temperature difference between the points, two given points. So here we are having the formula. There first we're given here t as a function of x and y, and dt will be equal to partial t by partial x into dx plus partial t by partial y into dy plus partial t by partial z into dz. Now the data given to us is, in addition to that, we're given the value of x is equal to 6, value of y is equal to 3, value of z equal to 2. And then we're given the value of, this is x2, xt, x3, and that gives me the delta x. So my delta x is equal to 6.1 minus 6.0, 0.1. And my delta y is equal to 3.3 and minus 3.0 is equal to 0.3, and my delta z, that's equal to, my delta z is equal to 1.98 minus 2.0, that give me minus 0.02. So as I explained you before, when the value is increasing, the increment will be positive. When a value is decreasing, increment will be negative. So we have a positive increment in delta x and delta y, and negative increment in delta z, because delta z is changing from 1.98 to 1.98. So my z1 was 2 and z2 was 1.98. So you are decreasing. So you get the increment as 1.98 minus 2.0, that gives minus 0.02. So here I have this one. Now I find the partial derivatives of the function. Function given to me is t. I just write in a different color to make it more clear and magnificent. X, y, z is equal to 8 times 2x squared plus 4y squared, and we are having here plus 9z squared power 1 by 2. So we are using chain rule. We first find partial t by partial x. So we are having the power 1 by 2, multiply by 8, we get here 4. I get here 2x squared plus 4y squared plus 9z squared. 1 by 2 minus 1 is minus 1 by 2. Then we are having the partial derivative of this one with respect to x, taking y, z as constant. So get here 4x. So when we simplify this one, we get here this equal to 16x over 2x squared, 4y squared, 9z squared power 1 by 2. This is my partial t by partial x. Now I find here partial t by partial y. Similarly to that one, we are having here the inside, we are using chain rule, and we are having here 1 by 2 multiplied is 4. Then come the function 2x squared plus 4y squared plus 9z squared power 1 by 2, as I explained before. Then you take the derivative of inside with respect to y. X is constant, z is constant, and we get here the value of this one is equal to, we get here 8y. We simplify this one, we'll get here this equal to 32y over get 2x squared plus 4y squared plus 9z squared power 1 by 2. We just take in denominator, the sign is changed. Now with respect to z, I find here partial t by partial z, partial t by partial z. Again, the outside, multiply by 1 by 2, we get here 8 multiplied by 1 by 2, we get here 4, into inside remains the same, 2x squared plus 4y squared plus 9z squared power 1 minus 1 by 2. Now you need to find the partial derivative inside with respect to z. My x is constant, y is constant. I'll get here 18 z, and then I simplify this one. I'll get here 72z over 2x squared, 4y squared, 9z squared to power minus 1 by 2, power 1 by 2. Now I just substitute in my partial d by dt in equation 1 here. In equation 1, we substitute here in equation 1, and we having d by dt is equal to partial t, and you can find this one is common. So I can simply take this one out, don't write it many times, and we can write here this 1 over 2x square plus 4y square plus 9z square for 1 by 2. Now in my dx we are coming here 16x into delta x. We say dx, and delta x we can write later. Here dx plus 32y dy plus 72z dz. So it's my formula. Now I can just substitute my values and I can get here result for this one. And I am having here my delta x is equal to dx. So what's my delta x? What's my dx? This is my dx is equal to delta x. This is my dy is equal to delta y. This is my dz is equal to delta z. I use these values, and the value of x and y z is given to me as 6, 3 and 2. This value is 1 over. We are having here 72 plus 36. The value of z is 4, 2. We are having here also 36 to power 1 by 2. So we are having the value of x. The value of x is equal to 6, and 6 square is 36 multiplied by 2 is 72. Value y is 3. 3 square is 9. 9 multiplied by 4 is 32. Z is 2. 2 square is 4. 36. And then here we are having is x equal to 6. We get here 96. Delta x is 0.1 plus y is equal to 4. We get here 12. And here is delta y. Delta y is equal to 0.3 into 0.3. And then we are having z is equal to 2. We get here 144. And delta z is equal to 0.02. So we are having this result, and we simplify this one. When we simplify this one, we get here the result of this equal to, well, here we get here 142 to power 2 is 1.12, 0.96 plus 0.36 minus we get here minus 0.288. Decimal places here, we get here 2.88. Further simplify this one, we get here 1 over 12, and we simplify this one. We get the result of this one after making calculation is 2.24, and that's my result for dt. So again at this stage we are just going to make our data, that is putting x, delta x, y, delta y, and z, delta y, delta z, and we simplify this one, we get the result. So this is the change we are having in the temperature, and this approximate change in temperature when this we are having the difference between these 2 points. When the points are changing, obviously the value of approximate value of temperature change will be also changing.